So in the last video, we got a basic introduction to what it means for something to be positive charged or negatively charged. In general, negative charges will only attract positives, and positives will repel positives, and negatives will repel negatives, but opposites attract, and like charges repel. So yeah, that's going to be the basis for this video. Say I have a sphere over here, and I have another sphere over here. Or you know what, not really a sphere. Say they're just little balls of charge. So I have this one over here, and we'll call this charge A. This will be QA. We'll denote QA and QB. These are just the names. Okay. Now, this may sound a little weird, but this one can have more charge than this one. So how can charge actually be defined? Well, to define it, we think about it as a force. So if something has more charge on it, it applies more of a repulsive force, or more of an attractive force to opposite charged things. So yeah, let's say in this case, this is a positive charge, and this one is a negative charge. So obviously, or not obviously, but they would attract one another with some kind of vector going directly towards the other one. Now, what does this depend on? Of course, it depends on the charges, as I've just said, but also depends on the separation between them. This is just like Newton's law of gravitation. So if I say that this distance is r, I can characterize the electric force, I'll call it F sub E, on each of these ones. They're the same forces. I would define this force, F sub E, is equal to some experimental constant multiplied by the magnitude of charge QB times the magnitude of charge QA. And if I was to divide that by the square of the distance between them. Now this has a name. This is Coulomb's law of electrostatic attraction. It looks remarkably similar to the law of gravitation. By that I mean we have a proportionality constant and we have a square in the denominator. It's another inverse square law. So if instead I move this one closer, say I moved it like 2 times closer, now this would have a 1/2 over here squared, that means we would have a 4 times greater force. So yeah, just keep in mind of that. But yeah, it's really cool to see the symmetry in nature, how this looks just like Newton's universal law of gravitation. And I'll write this over here if you want to look up more about it. This is Coulomb's law. And this proportionality constant is K is equal to 9 times 10 to the, what are the units again? Let me just see 1 second. 9 times 10 to the, 9th. Newtons times meters per coulombs. I probably could have figured that out, but I just wanted to get. This is how you would calculate electric force between two charges using Coulomb's law of electrostatic attraction.